Okay, this is a constant acceleration problem because the acceleration is gravity, which is in feet per second, so it's 32.2 feet per second squared. Because the ball lands at the same speed it takes off at, we can assume that the velocity is constant because we're only looking at where it takes off and where it lands. So 60 degrees, this will be sine 60, cos 60. Okay, now looking at the formulas, we have, because we have initial velocity, which is 40 feet per second, and we have the distance it travels, which is 15 to the middle and then plus d, so not to the middle, so 15 to where player B takes off, and then d, so s is equal to 15 plus d. And we don't know time. We can use the constant acceleration equation, which is v equals, no, sorry, wrong one. S equals s initial plus velocity initial times time plus 1/2 constant acceleration time squared. Okay, but because I forgot to mention this is the x direction that we're looking at right now. So because in the x direction the acceleration is 0 because it's a constant velocity, all of this becomes 0. So we are left with, I'm going to plug in the variables. So we have 15 plus d, initial displacement is 0, equals, so we have velocity, which we know is 40, but we're looking in the x. So we have velocity in the x, what? Sorry, and then we have 15 plus d, and then velocity we know is 40, but because it's in the x, so cos 60, so 40 cos 60. Okay. And time we don't know, t. So when we rearrange, we're solving for distance right now. So d, because the question asks us for determine the distance in order to make the catch, which is this d here. If you can see. So we're looking for d, so we can rearrange and we can get 20, which is this, 20 t minus, move the 15 over, minus 15. So this is equation 1. Okay, and then
the professional Rainbow Six Siege player.
And then we know that acceleration in the y is 32.2 feet per second squared.
Who fucking blows that wall?
Thanks for contributing, Wesley.
Oh.
And then 13 point, sorry, that's Wesley. He should be studying, but
Oh man, engineering is so easy.
to all my subscribers out there, he may or may not be cooked. Midterms in 36 hours, guys. How do we feel? I should start a podcast, like Talk Tua.
I mean.
Oh, the camera's on?
That's not. Good night, Russell. I mean, good morning, Russell.
We have to stay professional. Anyways,
Engineers.
for real.
You're gonna be someone later.
You can't have
To-
business with this video online.
No. Good old, good old. Okay. Now, because we're trying to solve for time. So t equals question mark. We don't know time. We know that velocity in the y is equal to 40 sine 60. Okay. So we know that the distance traveled, s equals 0, s initial equals 0. This is because it lands at the same height it starts at. So we can use the same equation, s in the y equals sy initial plus velocity y times time plus 1/2. This is negative 32.2 time squared. Well, I guess I was supposed to write. I was supposed to write time. So acceleration and then time squared. Okay, so fill in the variables. So this is, we can move this over, so this is 0 minus 0, which is just 0. Bam. So 0 equals 40 sine 60t plus half of that will be 16.1, but negative, definitely negative, because our coordinate system, which we established, would be like that. Acceleration is down, so negative 16.1 t squared. Okay. Rearrange for t, and we will get 2.152. Okay, this is equation 1. We're gonna plug back in. Plug into 1. D equals 22.152 minus 15. The distance is 28 feet. Boom. Okay. Now, because we know that the velocity at A is equal, in the x direction, is equal to velocity at B in the x, for the ball, we know that the runner B has to run at the same speed as the ball is going down. Or sorry, the ball is going in the x to catch it, because he's starting when the ball is directly overhead him. They both have to run at the same speed as it is going in the x to catch it, because he takes off as it's overhead of him. So that means that VBX is just equal to VAX, which was 40 cos 60. So this is 20 feet per second. So these are the 3 answers to the question.